Good morning, guys. Hope everyone is doing all right, doing your summer school online learning, guys. And we're gonna get started on chapter number 3. So chapter number 3 is it's called quadratic functions. Okay, and so the first topic is called the vertex form of a quadratic function. So just the quadratic function is it's a type of mathematical function, and I think what you guys are going to find is that throughout the rest of this course and through Math 30 as well, we'll be studying a whole bunch of different types of mathematical functions and how they work. Okay, so it's just that's what we're leading to for the next several units in your math course over here, and we'll kind of figure out how the properties, how these functions work, and how they work. And we'll be doing some applications and how you see some of these things in the real world and how they may be applied to other industries and other different fields of study as well. Okay. All right. So first thing, fill the table of values and sketch the graph of y equals x squared. So this is what I call our base quadratic function. So what I'm going to do for a table of values, I'm just going to put in a few negative values and a few positive values. Okay. Now, there are decimals in between all these x values over here like that. We're just doing it so we can get a general sketch. So if we have y equals x squared, the thing we need to be careful is if you put this into your calculator, this is going to end up giving you an answer of -9, where this is going to give you an answer of +9. Well, what we want is this one over here, because we want this the exponent 2 being applied to the negative as well. If you look at -3 squared, that means the squared is being applied to the 3, but not to this negative over here. And that's why we get an answer of -9 on your calculator here. So we want to be doing this one over here. So it's -3 times -3 is +9. Okay, and then -2 squared is 4, -1 squared is 1, 0 squared is 0, and we get these table values over here. Okay, so when we're going to plot this one, so here's our x-axis, here is our y-axis. We're going 3 to the left and up 9. So that's this dot right here. Now we're going to go 2 left, up 4, 1, 1 like this. And our graph looks like this. Okay. Now, like I said before, it's like this graph, they're not just these points over here. We do have all the decimals and everything in between them. So I'm going to go and connect the dots between this curve, and it looks like this. Okay, sorry guys, there should be a bit of a better drawing there. All right, so this is what we call our base quadratic function. This type of graph is called a parabola. Okay, so a parabola or a quadratic function, this is what we're talking about over here, this type of shape. Okay, couple things we have over here. This point over here, 0, 0 in this case, the origin, is what we call the vertex. Okay, another couple other things that we'll talk about more in our later on too. But if I draw a vertical line through the middle over here, and the equation of this vertical line is x equals 0. We call this the axis of symmetry. So the idea is that this graph is symmetrical about this line over here. Okay, so it's called the axis of symmetry. All right. State the domain and range of f of x equals x squared. So quickly just do a quick little sketch of what this graph looked like again. Here's our axis, and this graph looked like this and like this. Okay, so if you remember what domain means, this means the set of all input values. I'm going to put in bracket our x values. The range is the set of all output values. So, and these are y values. Okay, so in this case, if you look at this graph keeps going forever to the left and forever to the right. Here's how we're going to write our domain. So a domain, and we're going to use set notation for this. So this I call these fancy brackets or these parentheses, or what we use for set notation. And this could be a bit of a review from Math 10. Okay, so here's what this says. This is saying the domain is all values of x this line means such that. Sorry guys, I got a very fine mouse button over here, mouse button that just clicks and goes to the next page all the time, such that x is a real number. So this is like kind of this is what this notation is telling us. Is the domain is all values of x such that x is a real number. So in other words, it is any or all numbers for x. All right. Now, when I'm talking about the range, it's going to look very similar. But our range, let's put this over here, it's going to be this. It's a set of all y such that y is greater than or equal to 0, comma, yer, like this. Y is now in real numbers. So what this is saying is that there's all y values, but y has to be bigger than or equal to 0. And so if you think of this graph, it never gets negative over here, right? So it never comes down below the x-axis over here, right? So our y values are all going to be positive numbers. Okay, well, I'm going to say non-negative because we're including 0 as well. So it's all y such that y is greater than or equal to 0, where y is a real numbers. Okay, so there's a domain and range. Okay. So this question over here says state the vertex of each parabola. Made a little Desmos thing over here. If you guys use Desmos, you know it's a great program. And it's kind of an online calculator for us. All right, don't worry too much about this guy over here. Again, in fact, I'm even going to unhighlight this guy over here. So what we want to do is we want to do y equals x minus 5 squared. Okay. So what this looks like, if we look at just our regular y equals x squared, y equals x squared. So this is our regular parabola. The vertex was at 0, 0. Okay. Now in this case, it's y equals x minus 5 squared. We're getting this guy over here. Okay. So now I guess the ask is well, if I'm saying x minus 5, why am I actually going to the right and not to the left? Okay. And the reason why this is the vertex over here is because 0 squared equals 0. Okay. And that was the smallest point that we have. Okay. Well, so how do I get a 0 here? Okay, well, the way I get a 0 here is by putting x equals 5, because 5 minus 5 is going to be 0. So that's why the vertex has moved 5 to the right, in this case over here. Okay, so the point we're trying to get out of here is when we go x minus 5 squared, we're going 5 to the right. When we go x plus 3 squared, hopefully you guys can see that we should be going, we're not going to go 3 to the right, we're actually going to be going 3 to the left. So when we go x plus 3 squared, what's happening here is we have to think, well, what value of x is going to make this whole part inside the brackets equal to 0? Okay, so if I have a negative 3 in here, okay, negative 3 plus 3 is 0, 0 squared is 0, which is that could be the vertex of this guy. Okay, so it's almost kind of a bit backwards over here. If you see an x plus 3, and I'm going to say inside the brackets here, we're actually moving 3 to the left. If we have an x minus 5, we're actually moving 5 to the right. Okay, so the graph we're looking at over here, x minus 5 squared was this guy over here. I'm going to show you how I'm getting these points in a second here. So if I start over here, here's the vertex. Okay, so our vertex has moved 5 to the right. Okay, now starting at the vertex, if I go 1 to the right, 1 squared is 1. That means I'm going 1 up. If I go back to my vertex, if I go 2 to the right to here, 2 squared is 4. I'm going 4 up. If I go 1, 2, 3 to the right, 3 squared is 9. I'm going 9 up. Okay, same thing going to the left. If I go 1 to the left, it's negative 1. Negative 1 squared is 1, so I'm going to 1 up. Negative 2 squared is 4. Negative 3 squared is 9. And I get my graph looks like this. Okay, x plus 3 squared. So this same thing, but now we're moving a 3 to the left. So 1, 2, 3. Now the same rules I was following before. So here's my vertex. If I go 1 right, 1 squared is 1. 2 right, 2 squared is 4. 3 right, 3 squared is 9. 1 like this. And this graph looks like this. So this was y equals x minus 5 squared, and this is y equals x plus 3 squared. Okay. The point is, x plus 3 is taking my vertex, moving it 3 to the left. X minus 5 squared is taking my vertex, moving it 5 to the right. All right, so state the vertex. Okay, so the vertex was 5, 0. This vertex is negative 3, 0 here. Okay, going back to our Desmos graph here, x squared plus 4 and x squared minus 6. Ignore all this stuff for a sec. We have y equals x squared plus 4. Okay, so how is this guy a bit different? Okay, well, obviously it's 4. We had a 3 and a 5 in the last example. But the other thing is, like in the previous example, is like we had the numbers were inside the bracket being squared. In this case, they're not. Okay, so we're squaring the x and we're adding a 4 to it afterwards. Okay, so if I put an x value of 0 in here, for example, 0 squared is 0 plus 4 is 4. That's going to be my minimum value over here. If I put in a value of 1, 1 squared is 1 plus 4 is 5, and that's this point here. Negative 1 squared is 1 plus 4 is 5. Okay, so what this plus 4 has done over here, if I put a plus 4 outside the brackets, it's going to be shifting the vertex of the parabola up 4 units. Same thing for the other one, where y equals x squared minus 6. This is going to be moving this guy 6 units down. Okay, so the same idea over here. Okay, so the parabola, the shape of the graph is exactly the same. It's just been shifted up or it's been shifted down. Okay, so the plus 4 moved the vertex 4 units up. The minus 6 moved the vertex 4 units down. All right, so back to our thing over here. So I'm going to quickly sketch each of these guys over here. So this one was 1, 2, 3, 4, and the vertex was like up like this. Okay, so our vertex is 0, 4. In this case, 1, 2, 3, 4, 5, 6. Our vertex is here, and our graph is opening up like that. Okay, so this vertex is 0, negative 6. All right, combining both of these ideas for this question over here. So we have to think, what does this minus 6 do? This minus 6, I'm going to say it moves, and in bracket I'm going to put translates. So this is the mathematical word we use for shifting a graph. It translates vertex 6 units right. This minus 8, which is outside the brackets, I'm going to say it translates or moves 8 units down. Okay, so what's this graph going to look like? It should be translated 1, 2, 3, 4, 5, 6 to the right, and then 1, 2, 3, 4, 5, 6, 7, 8 down. So it should be over here. Okay, and this graph is going to be like opening up like this. Okay, so we're talking about the domain and range. My domain is going to be same as my last one. This guy's going forever to the left, forever to the right. Oops, pretend that's not there. Let me do this again. Domain is all x such that x is a real number. Okay. Our range is set of all y such that y is greater than or equal to -8. Okay, it's starting at -8, going up, and sorry, I should be putting y is a real number in there too. All right, so there's our domain and range for this guy over here. All right, now so we're talking about this -x² + 7 thing. What's that going to do? So when we do y = x², we have a parabola opening upwards. Okay, now when I say it's opening upwards like that, well, it's starting here and it's going upwards like this. Now, what happens if I put a negative out in front of it? Okay, so what I'm seeing here is we now have a parabola opening downwards. Okay, and why is this happening? So the way this is written over here, this squared is being applied to the x, but is not being applied to the negative out in front. Okay, so if I put an x = 2 in here, 2 squared is 4, with a negative in front is -4. So when x is 2, y is -4. Okay, when x equals -3, -3 squared is 9, but I have this negative in front of it, so it's going to be -3, -9 is going to be down here. Okay, so -3, -9 is going to be this point down here. Okay, so if we have negative in front of this parabola like this, that means that we're going to say the graph has been reflected in the x-axis. That means the graph is going to be opening downwards now instead. Okay, so there's been a vertical reflection in this graph here. Okay, and that's what this negative does. So in this case, this negative parabola opens down. Okay, this 7 translates up. So this graph is going to be, it hasn't been shifted left or right as well, but I've got 1, 2, 3, 4, 5, 6, 7. This graph is opening downwards like this. This is really frustrating right now, guys. Sorry. All right, so this graph is opening downwards like this. Okay, so our domain is x such that x is a real number. Our range is y such that y is less than or equal to +7, and y is a real number. All right, so here's going to be how we do domain and range of these guys over here. Okay, example 6. Determine the equation of each parabola in the form y = x minus p² plus q. Okay, so all we're doing right now is we're kind of identifying where our translations are. Okay, so first of all, what's our vertex here? Our vertex is 1, -5. Okay, now when I say x minus p² plus q, we tend to use p and q as the coordinates of the vertex. Like this. Okay, p and q are going to be the coordinates of the vertex. In this case, now I think it's a little bit confusing here. Is this is x minus p? Well, in this case, my p value is 1. So it's going to be x minus p, which is 1 squared. My q value is -5. Okay, so it's going to be plus -5, which is saying the same thing as -5. So it's going to be y = x minus 1 squared minus 5, and it's going to translate my graph 1 to the right, 5 down, still opening up. Similar idea for this guy over here. Our vertex is -3, 1. So when I'm saying x minus p², my p value is -3. So it's x minus -3. Now I'm going to simplify this in a second here. Plus 1. My q value is 1 here. Minus negative is going to become y = x plus 3². Okay, so we saw this earlier on where like if we have an x plus 3 inside the brackets, we're actually going 3 left. Okay, so we're going to see this guy just like that. All right. All right. sorry guys, this should have been like part B, like right here. So by plotting the graph, okay, negative 2x squared. So when I plot the graph for this guy here, I want to see a table of values here. Negative 2x squared. So I'm doing the same thing that I did in my last example, like this. Okay. So if I go y equals negative 2x squared, I'm plugging a negative 3 into that. So what's going to be is negative 2, and then in brackets, negative 3 squared. So the thing we need to remember is that this squared is being applied to this x. It's not being applied to the negative 2, okay, because there are no brackets around this negative 2 and the x over here. So this squared is only being applied to this. So this is following like our bed mass rules or our order of operations that I hope you guys remember from junior high. Okay, so we apply the exponent to the x, but not to this part over here. So in this case, it's going to be negative 2, negative 3 squared is 9. That's going to be negative 18. So this is negative 18 here. So we have negative 3, negative 18 way down here. Okay, this is going to be this point. So put in negative 2. Negative 2 squared is 4 times negative 2 is negative 8. So it's going to be negative 2, negative 8. When I go negative 1, so negative 1 squared is 1 times negative 2 is negative 2. 0 squared is 0 times negative 2 is 0. And it's going to be the same thing going this way. It's going to be symmetrical over here. Okay, so 1 squared is 1 times negative 2 is negative 2. 2 squared is 4 times negative 2 is negative 8. 3 squared is 9 times negative 2 is 18. So we're seeing this parabola over here. Okay, now the other way, okay, so when I say like using the patterns from quadratics, here's what I mean by that. If you saw in the what I talked about earlier on was like if you say that the vertex, if you go 1 to the right and 1 squared is 1. Okay, so if I start at the vertex, if I go 1 to the right is 1 squared is 1, but then multiplying times negative 2, so I'm going negative 2 down. If I go 2 to the right, 2 squared is 4 times negative 2 is negative 8. I'm going 8 down. 3 squared is 9 times negative 2 is negative 18. And it goes down like this. Okay, so that's how we can kind of plot these points without having to do this table of values every single time to be able to get a graph like this. Okay, bit of a trickier question here. Determine the equation in the form y equals ax minus p squared plus q. I just want to back up for a second here, so I just want to talk a bit more for this one. When I'm saying what's this negative do, this negative gives a vertical reflection, we call this. Sometimes we'll say this is a reflection in the x-axis, okay? So frustrating, guys, I'm sorry. All right, so that's what the negative does, okay? Now, the 2, when we say this, we call this guy a vertical stretch. So if you think that this graph's been stretched vertically by a factor of 2. Okay, so this is a vertical stretch by a factor of 2. This is a vertical reflection in the x-axis, is how we do it. What we call the negative does and what the 2 does here. All right, so back over here. In this case, the P and the Q are the vertex, or is the vertex, is vertex. The A is what we call the vertical stretch factor. If A is negative, there's also a vertical reflection in there as well. And so this guy's opening downwards, so we know that A should be negative when we do this one. So when we do this one, what we're figuring out is we know that this is our P value, this is our Q value. Now what we need to figure out is what is our A value. In order to do that is we're going to use that by using this point over here. So anytime that we say that, so we have a vertex and the graph is passing through this point over here, so passing through -3 and -1, we're going to call this guy the x and the y. Okay, so when we're doing this, the negative 5 gets substituted into p. The 7 gets substituted into q. The negative 3 gets substituted in for x, and the negative 1 gets substituted into y. But the only thing we have left is this a value. So we're going to solve this equation for a. So this is going to be negative 1, that's my y value, equals a. So I don't know what that is, bracket, negative 3 minus negative 5. Okay, be careful here with the, remember it's x minus p, and my p value is negative 5. So negative 3 minus negative 5 squared plus 7. Okay, so now we're just going to go ahead and we're going to solve for a. Okay, so I'm going to go minus 7 like that. Get rid of this guy over here. Negative 1 minus 7 is negative 8. And negative 3 minus negative 5 is the same thing as adding the opposite, is going to be 2 squared. So negative 8 equals a times 4. And now I'm just going to divide both sides by 4, like this. And I get negative 2 equals a. So we get y equals negative 2, x plus 5, and the same thing as x minus negative 5, which becomes x plus 5 squared plus 7. And that's how we figure out the equation of this graph. Let's look at this one. All right, similar idea over here. Okay, we have our, so as we're given a graph where we have our vertex is here, and it's passing through these points over here. We're actually giving you the two x-intercepts over here as well. Okay, but so what we're going to do is we're going to count. Here is our p and our q, and it doesn't matter which point I use, but I'm only going to use one of them. I'm going to use this as my x and this as my y here. Okay, so plugging this in, my y value is 0 because it's this one here. I do not know a. My x value is 5. My p value is 2. My q value is negative 3. Okay, so now I'm going to go and add a 3 to both sides. 3 equals a. 5 minus 2 is 3. Squared is 9. Divide both sides by 9. Now 3 over 9 simplifies to 1/3. And that's going to be my a value here. So I got 1/3. So y equals 1/3 x minus 2 squared minus 3. All right, guys, I hope this kind of makes sense. It's definitely going to take a lot of practice for you guys to kind of get good and proficient with these questions over here. So please keep up to date with the textbook questions. And as always, guys, send me a message if you guys have any questions. All right, see you in the next video.